So again, we want to use the inverse method to solve this. But first we need that coefficient matrix and the inverse of it. So let's write down the coefficient matrix. What is it? 2, negative 2, 3. 1, 0, negative 1. Negative 2, 1, 0. And then what am I going to augment that with?
1, 0, 0, 0, 1, 0, 0, 0, 1.
IJ, I like how you said IJK. There's truth in that, but it's kind of a different context, isn't it? IJK is row vectors. Yeah. But let's think of that as a matrix on the right, the identity 3 by 3 identity, right? So that's the A augmented with I part. And then, we need, you guys, I haven't shown you an example of Gaussian elimination in a while, so this is something you need to see. Remember what you do. You work column by column from left to right, and you want to identify your pivot in any particular column and use the row with the pivot to get the zeros below it. So we're going to go for row echelon form first from left to right, and then we'll work from right to left to get it in row reduced echelon form. So your pivots don't have to be 1, but it's so easy to switch row 1 and row 2 that I'm going to go ahead and do that because a pivot of 1 is kind of nice to work with, but again, it's not required. So that's how I'm going to notate switching row 1 and row 2. And I'm just going to do the switch and rewrite the matrix. The reason you're rewriting the matrix is for the person who grades it. It helps me grade it. It'll help you get a better grade if I can see what you're doing. So 1, 0, negative 1, 0, 1, 0. Hold on. 1, 0, negative 1, 0, 1, 0. And then middle row, it becomes negative 2, 0, 2, negative 2, 3, 1, 0, 0. And then it's hard to talk at the same time as doing this, so make sure you're checking my work as I go. Row 3 hasn't changed. Everybody good there? Now, row 1 is always the current row 1. Row 2 is always the current row 2 of the matrix you've just rewritten. It's always changing. Okay, so we're going to use what? You don't have an option at this point. If that was your first step, then what's your pivot in the latest matrix? That's it. And you have to use that row 1, to do row operations to get zeros below. You don't have a choice, okay? I like you guys to have choices. I like free choice. I like freedom. But in this case, it's an algorithm. You guys are robots. Normally, you're not. In real life, I want you to think. But here, you're a robot, and at this point, you don't have a choice. There's some choices. I didn't have to switch row 1 and row 2. I could have taken 2 as my pivot in the first step, but I thought this would make it a little nicer. All right, so let's write down the row ops. To get a new row 2, what am I going to do to the current row 2? I'm going to take the current row 2 and do what? No, you are not. I'm glad you said that. I'm actually glad you're wrong because it's not a test. You could get a 0 by adding row 2 and row 3. It's not Gaussian elimination if you do that. Please don't do that because then I have to take off points. I don't want to take off points on the test, right? So you're not allowed to get it any old way. You're only allowed to use the row with the pivot to get the zeros. Okay, so your new row 2, you're going to write down the row that you're replacing first. This is the notation. You're going to take what? You're going to subtract off what? 2R1, right? And then this whole thing becomes the new R2. That's what that arrow represents. Does everybody believe that? Okay. And then let's symbolically represent the new row 3. So write down the row you're changing, and you don't multiply that by anything. You're not allowed to do that. Not that you would in this case anyway. You're not allowed to multiply anything times the row you're changing. What you do is you multiply something times the pivot row. So what would you do here? You would add, since it's a negative 2, you would add 2 plus the pivot row. And that's going to be your new R3. Does everybody see that? I am going to want to do some scratch work here. What I'll do for this first one is I'll write down -2 times row 1. So -2, 0, 2, 0, -2, 0. Check my work. Add it to the current row 2, 2, -2, 3, 1, 0, 0. And that is going to be your new row 2. Hopefully you get a 0 for the first guy. -2, 5, 1, -2, 0. You might label it row 2 so you don't forget. And then for scratch work, let's get the new row 3. And so we're going to multiply just by 2 now. So we're going to double row 1, get 2, 0, -2, 0, 2, 0. Add it to row 3, -2, 1, 0, 0, 0, 1. And we get 0, 1, -2, 0, 2, 1. We finished off the column, rewrite the matrix. Every time you finish a column, the rule in this class is you got to rewrite the matrix. If you're programming a computer to do this, of course, the computer doesn't need to rewrite the matrix. 0, -2, 5, 1, -2, 0, 0, 1, -2, 0, 2, 1. And you don't really need that bar right there. Okay, so you finish the first column. Now we go to the next column, and which one is your pivot? No, pivots go down in that stair-step pattern, right? So you're going to have one.
Yeah, but can't you swap 3 to 2?
We could, but we're not going to because I want to show you something. You're not, okay, if you swap it, you got to do that first.
Yeah.
And then identify your pivot, right?
Yeah.
So we're not going to swap it. We could, but I want to show you something. I want to make a point here with what some of these row operations look like. So we're going to use -2, and I'm not going to turn it into a 1 because I want to show you what happens when you don't do that. It's still not bad. All right, so I need to get this guy to be a 0, right? Now this guy's my row 1, this guy's my row 2, this guy's my row 3. Row 1 hasn't changed, but the other 2 did. Okay, so what? Okay, so that's a new row 3. I want to get that 1 to be a 0, and so that is a new row 3. Okay, so what am I going to do to my pivot row, which is row 2 now, so that when I add it to row 3, I get a 0? So is that +2, row 2? And then that's my new row 3. All right. So, is that right? No. Okay, there you go. Should be 1/2, right? All right, so if you do that, yeah, you get fractions, but that's okay. We can handle it. Okay, so 1/2, so 0, you get, what do you get? You get -1, right? And then 5 halves, and then 1/2, and then -2 halves, which is what? -1, and then 0. And then we're going to add that to row 3, which is 0, 1, -2, 0, 2, 1. And what does that give us? 0, 0. Okay, 5 halves plus -4 halves. That's what -2 is. So 1/2, 1/2, 1, 1. We finished the column. So rewrite the matrix. Row 1 hasn't changed. 1, 0, -1, 0, 1, 0. Row 2 hasn't changed. 0, -2, 5, 1, -2, 0. Row 3, that's what I just wrote down. 0, 0, 1/2, 1/2, 1, and 1. And this is row echelon form. Now, once you get it in row echelon form, Gaussian elimination then says go back to the left, from left to right on the last column you were working on, get your 1s and then the 0s above. Okay, so what am I going to do? I want to rewrite the matrix with the correct pivot. So 1, 0, -1. Row 1's not going to change. I'm not going to do row 2 yet. One column at a time, one pivot at a time. Okay, row 3. I need this 1/2 to be a 1. So what do I multiply through by?
Double.
Just double it. 0, 0, 1, 1, 2, 2. Does everybody see that? If you wanted to notate that, that would be 2 times the current row 3 becomes the new row 3. That's how you would notate that. Okay, is everybody with me so far? Okay, then what are we going to do? The rule is to use this 1 to get zeros here and here. Okay, let's do that, and then we'll be just about done. So that means what? I need a new row 2. So this guy's row 1, this guy's row 2, this guy's row 3. I need a new row 2. Write down the row you want to change. Then what are you going to do to your pivot row, row 3? Minus 5 times row 3. Does everybody buy that?
Yeah.
And then we can just add row 3 and row 1 to get the new row. So this is a new row 2. And then we're going to add row 1 and row 3 to get the new row 1. So 0 is above that 1 right there. Okay, so so row 3 is not going to change. I'm going to write that one down. And then, okay, let's see if we can do this one real quick in our heads. Negative 5 times row 3 plus row 2 is another way to think about it. So if we multiply 5 times 0, that's 0 plus 0 is 0. 5 times 0 plus 2 is negative 2. 5, or negative 5 rather, times 1 plus 5 is by design 0. Negative 5 plus 1 is what? Okay, negative 5 is negative 10 times 2 is negative 10 minus 2 is negative 12, or plus negative 2 is negative 12. And then negative 10 plus 0. Does everybody buy that? And then add, to get the new row 1, add row 1 and row 3. So 1, 0, which is nice. 0, bless you. And then 0 plus 1 is 1. Check me on this. 3, or I'll check it because I have the answer written down. Okay. And then almost done. What do we need to do to get the final answer?
Multiply row 2 by negative.
So we're going to multiply. I'll notate it later in the notes, but just to get you out of here somewhat on time, we're going to go ahead and multiply row 2 by negative 1/2. What does that get us? Or divide by negative 2. What do you get? 0, 1. You better get 0, 1, 0, right? And then is it 2, 6, and 5? And then 0, 0, 1. The third row hasn't changed. So do you guys see the inverse? So there's the inverse. That is A inverse. And then the inverse method says to take A inverse. So X, the vector X from that system above, is going to be A inverse times B. B was negative 5, 5, negative 4. And then all I have time to do is give you the answer, but that's just a matrix multiplication. You should be able to show the work on that multiplication, but ultimately you should be able to get 2, 0, negative 3. And so that's your X, your Y, and your Z.